Hi, my name is Xiaoyi Tian. I'm a PhD student at the University of Florida. I'm going to present our paper, Designing a Chatbot for Effective Study Habit Behavior Change. First-year college experience can be very challenging. Transitioning to a new environment, many students don't have appropriate study habits and skills to survive in a highly competitive environment. Especially in computer science, lots of past work has shown first-year CS students struggle. In addition, given the COVID-19 situation, students in many countries are still adopting certain levels of remote learning, where students require more support. Prior work has shown chatbots to be effective tools for inducing and sustaining behavior change. Similarly, we were interested in building off this prior work to explore the design and use of chatbots for university first-year students majoring in computer science. The rest of my talk will cover different stages of designing our chatbot. First, I'll introduce how we come up with our design by learning from users. I'll describe the system features and prototypes. Then I'll present the evaluations and design recommendations. And finally, the conclusion. Here, we would like to acknowledge that the study data we collected during each design stage are both prior to the pandemic and during the pandemic. The findings discovered from this para-pandemic data may be influenced by the disruption in higher education delivery in the United States that was happening at the time of our studies. So let's begin with the design inquiry. In the design inquiry, to understand students' issues related to study habits and skills, we interviewed 3 peer tutors and distributed 83 in-class surveys. From the interviews and survey, we found that first-year students are facing some common challenges like time management, task management, lack of domain knowledge, and they're not familiar with some academic resources. They expressed great interest in using a chatbot for study behaviors, also perceived useful of the design features we proposed. The design inquiry findings inspired us creating a chatbot called StudyBuddy. So we are moving on to the system features and prototypes, which is the middle part of this design flowchart. StudyBuddy has 6 features, which contains number 1, sending computer science insider tips, 2, sending reminders for completing tasks on time, 3, connecting students to a human tutor, 4, assessing and providing feedback on how well students are practicing the study habits, 5, break down large tasks to smaller, more manageable parts. And last, recommending appropriate academic resources. Among these features, we implemented 4 of them as high-fidelity prototypes as a Slack app. Slack is an instant messaging tool that is widely used among workplaces. Note that for the Insider Tips feature, considering the situation of computer science, we offered 2 types of tips. Functional tips are task-related suggestions, such as visualizing code. And this type of tip aims to inspire students when they are working on their programming tasks. Motivational tip involves more psychological support, such as encouraging students taking a break. We found students perceive differently on these 2 types of tips, which we will discuss in the next few slides. Then the remaining 2 features involves more complex interaction. We choose to use low-fidelity prototype storyboards to demonstrate these features. We designed 3 storyboards. Each represents different levels of interaction complexities. And the story is about how StudyBuddy helped a CS student called Helen on completing her assignments. Finally, we evaluated the chatbot usability and offered design recommendations. We first piloted the design through interviews with 8 student users. Using the feedback gathered from these interviews, we designed a larger scale usability survey to understand their expectations. We also conducted interviews with 5 course instructors to better understand the potential use of StudyBuddy from educator perspectives. Gaining insights from multiple stakeholders help us understand how to maximize the benefit of our target user and how to promote a better collaboration among students, tutors, and instructors. As a result, in this paper, we offered 5 design recommendations, including building trust with users, personalizing the chatbot experience, as well as context awareness, incorporating gender and individual differences, and balancing between immediate help and long-term sustainable support. Due to time constraints, I'll only highlight 3 of them in this short presentation. The first one, we observed a variation among users' preferences. For example, when we asked participants to rank their perceived usefulness for different tips, some students prefer functional tips as he thinks that's the only way helping succeed in the project. However, another student seemed to value motivational tips because of potential rapport building. Like this student said, I'll feel closer to the bot if it has a fun personality. Thus, our design lesson learned here is to personalize each individual's experience based on their preferences. Second, in the usability survey, we evaluated their chatbot acceptance using a framework called Unified Theory of Acceptance and Use of Technology. This contains 6 constructs that measure their technology acceptance from different angles. For more detail on this model, please check out our original paper. A high-level takeaway from this model is the behavioral intention, meaning whether they intended to use our chatbot in the future, were scored generally high. We also found female students expressed higher ratings for almost all of these constructs than males, including higher trust, effort, performance, satisfaction, and behavioral intention. It seems that our chatbot is particularly appealing to a specific group of users than others, and this presents important design considerations. Perhaps a universal design for all types of learners is less effective, so we need to consider prioritizing those who are in higher needs. Next, in the student survey, we asked students to rank our chatbot features, and this figure shows students' ranking. And similarly, we also asked instructors' perceived usefulness of these features, which we will contrast the specific ones in more detail. For example, breaking down task feature was favored a lot by students, and they think smaller, more actionable tasks will help them get started more easily. Whereas instructors think overly specific breaking down of tasks will hold their hand too much, that would prevent them forming essential skills for the future. The least appreciated feature by students is recommending academic resources, and they said they prefer Google. However, instructor thinks what they teach is different than what the internet provides. The chatbot can find resources that fit them the best given their current situation, rather than pure internet searching. Overall, it seems that students favors more on features that offers instant help, like breaking down tasks or sending reminders, whereas instructors value more about long-term sustainable support. So that leads to our design recommendation that it's balancing between immediate help and long-term sustainable support. Study habits take time to practice and instill, but can a chatbot still be useful as students grow and mature? It's important for future systems to consider how to adapt the same individual's improvement over time so it can be a consistently useful tool. Moving on to future work, we see a lot of directions on how to extend it using in a university learning environment, as we discussed in the paper. To summarize, here are 3 key takeaways for you to remember. Our prototype of chatbot to improve study habits was perceived useful by students, although it was influenced by factors like gender and individual experiences. In designing a chatbot for behavioral change, we need to personalize the experience based on the user and context. To ensure continued use, a chatbot should balance between offering immediate help and long-term sustainable support. Finally, thanks to my co-authors, and thank you for watching my presentation.